A modern data center is an incredibly dense, multidisciplinary build. Delivering thousands of interconnected components on a rigid schedule requires exact data. But early on, a project's data is often unverified, creating a dangerous gap between what a schedule claims and what the ground truth actually proves. We are looking at the Week 1 reporting cycle for a new data center project. The reporting period runs from August 1st through August 7th, 2022. This early baseline is managed by Nexora Engineering and Construction, who act as the main contractor responsible for coordinating both the civil, structural, and architectural scope, alongside the mechanical, electrical, and plumbing work. At the start of a build, any positive momentum feels like a win. If a schedule shows physical progress tracking ahead of plan, standard project management might accept that as a success and move on. This executive dashboard shows the approved plan required 0.016% progress. Actual progress sits at 0.02%, leaving a positive variance of 0.004 percentage points. But that tiny green variance hides enormous exposure. Cost data is marked not evidenced. Workfronts are constrained by unreleased permits, and MEP commissioning is completely stalled. This exposes the core principle of mature project controls. No status is marked green without current physical evidence, accountable acceptance, and a closed action trail. Because engineering and procurement dashboards are missing from this Week 1 report, the baseline and date used to calculate that progress remain formally unconfirmed. A 0.004 percentage point gain in early enabling works provides no real schedule protection. That microscopic physical progress cannot mathematically offset the risk of digging without confirmed utility permits or building without issued for construction drawings. To control the MEP and early civil works, we have to look at how information actually reaches the field. Document control must be governed strictly by the construction need date, rather than the date a subcontractor happens to submit a file. This rigid procurement workflow releases long lead equipment. Packages must clear strict verification gates: technical approval, PO, vendor data, factory acceptance test, and delivery. Failing to provide approved specifications at the first gate locks the entire sequence. You cannot issue a PO without approved technical constraints. This is why the management team must identify every single piece of long lead equipment and define its factory acceptance test obligations right now, in Week 1. Pushing through an out-of-sequence purchase order without closing those technical gates first guarantees site rework down the line. Securing the technical foundation for the factory acceptance test is far more critical to the schedule than simply rushing to buy parts. We see this exact exposure in the electrical scope. This covers the incoming utilities, backup generation, and the critical power distribution that keeps the data center alive. In the Week 1 report, the highly technical design evidence required for this system, specifically the load flow studies and the protection relay settings, are marked as not evidenced. This map shows a critical power network topology. Building this requires approved single-line diagrams, cable schedules, earthing details, and monitoring system points, but none are evidenced here. Without traceable configuration controls, the entire electrical subsystem stalls at commissioning level 0. Later in the project, the installation will demand exact testing metrics to prove it is safe, relying on verified torque values, insulation resistance and high pot testing, and strict room cleanliness records. Moving heavy equipment onto a concrete pad looks like progress, but physically installing backup generators and PDUs has no value if the underlying topology and protection relays lack traceable, approved configuration controls. For highly integrated life safety and public health piping, the immediate priority is establishing strict governance, rather than prematurely reporting physical progress. Before a single pipe is hung, the design team must provide verified prerequisites for the fire alarm networks, the smoke and heat detection layouts, and the suppression interfaces. This cause and effect grid explicitly links a suppression system hazard trigger to immediate cross-system responses, like HVAC shutdown protocols. To claim functional status, the contractor must resolve missing inputs like tank access and impairment controls, and produce physical installation evidence like hydrotesting results. Without that documentation, physical pipes and pumps are just stranded assets on a construction site. They cannot be tested or handed over until their exact operational parameters are linked within the turnover management system. the digital controls and security systems present an even harder challenge. Their architecture is largely invisible, yet it governs the entire facility's operation. In Week 1, foundational network requirements are unevidenced. The project lacks the data point maps, optimization rules, and validated cyber boundaries dictating how the building communicates. A subcontractor cannot simply bolt server racks into the floor. The physical placement relies entirely on approved time synchronization, note permissions, and controlled software deployment. This staircase shows the MEP commissioning framework. It is an active, escalating governance process starting at level 0 with design reviews. It demands absolute discipline as it climbs through initial energization, functional performance testing, and finally into integrated failure scenarios at level 5. Future operational acceptance is strictly preserved by the design and procurement decisions made right now in Week 1. You cannot test your way out of a broken supply chain or a missing configuration file. To enforce this discipline, the project tracks critical constraints immediately. For early civil works, the primary risks lie buried in the ground, shown here on a thermal risk map, mapping unresolved utility lines. If the utility interface lead has not formally signed off on the survey, scanning, and trial pit data, that absence directly and physically halts the workfront release. Excavation cannot proceed without it. This exact logic applies to the management meetings themselves, specifically during the prior cycle action review. In standard project management, teams often close open actions based on a verbal agreement or a narrative update. On this project, attempting to close an action with a narrative is instantly rejected, leaving the item open and at risk. An action closes only when the accountable owner submits objective evidence and the defined verifier formally accepts it. The weekly project meeting is exclusively a decision and assurance record. It is a tool for identifying authority gaps and unresolved interfaces, not a photographic diary of site activity. This brings us to the operational rule for Week 2. Any system that reports physical progress without a linked verified asset tag automatically reverts to a status of not evidenced. The management team enforces this data requirement financially. Subcontractors are forced to directly link their completed inspection and test plan releases to their payment certifications, ensuring data arrives before the cash leaves. The immediate recovery decisions for the next cycle are clear. The executive team must approve the integrated baseline, engineering must release a measurable 2-week look-ahead, and the MEP leads must confirm the Level 0 commissioning governance matrix. Visibility does not equal control. True project control in a data center environment is only achieved through verifiable, closed-loop evidence chains. Without them, purely narrative reporting is entirely obsolete.